Your ability to see what's around you is facilitated by light. Light is a type of wave. While you cannot actually see the wave, it is mathematically represented as such. In this photo, the wave you see is represented by something called a sine function. Another thing to note is that light waves with larger amplitudes will be brighter, and light waves with smaller amplitudes will be dimmer. We see different colors of light because light can have differing wavelengths. In other words, light waves that are closer together will have different colors than light waves that are farther apart. Visible light is just one part of a larger spectrum of waves called the electromagnetic spectrum. Electromagnetic waves, regardless of type, travel at the speed of light. For reference, something traveling at the speed of light is able to go around the Earth over 7 times in a single second. On this diagram I have here, moving to the left shows an increase in wavelength. This means that radio waves have the longest wavelength and gamma rays have the shortest wavelength. When wavelength increases, there is a decrease in frequency because the waves are further apart, meaning that it takes more time to get from one to the other. This decrease in frequency also leads to a decrease in energy. Therefore, moving left across the electromagnetic spectrum shows a decrease in energy because the wavelengths are longer. Radio waves have the lowest energy and the longest wavelengths, sometimes spanning kilometers long. Radio waves, as their name suggests, are widely used for communication purposes. Radio towers, for example, emit this type of electromagnetic wave. Next, there are microwaves. As you can likely imagine, they are used by microwaves to cook food. Next, there are infrared waves. They are typically emitted by fires or radiators. Then there's visible light. This is the only slice of the electromagnetic spectrum we are able to see. It just refers to any of the colors around us. For ultraviolet rays, we are unable to see them, though many insects can. This type of electromagnetic radiation is also emitted from the sun, and it can lead to sunburns. This is why we wear sunscreen outside to protect ourselves. Next, there are X-rays. They are used by X-ray machines, providing insight into our bodies. Lastly, there are gamma rays, having the shortest wavelength, greatest frequency, and greatest energy. Specifically, the wavelength is comparable to the size of an atom's nucleus. Gamma rays are emitted by lightning and other high-energy phenomena. In this video, we went over 7 types of electromagnetic waves: radio waves, microwaves, infrared waves, visible light, ultraviolet rays, X-rays, and gamma rays. To remember all of these categories, we can use the mnemonic "Raccoons make interesting voices" using xylophone games, where the R stands for radio waves, M stands for microwaves, I stands for infrared waves, V stands for visible light, U stands for ultraviolet rays, X stands for X-rays, and G stands for gamma rays. To recap, the electromagnetic spectrum is composed of different types of waves having varying wavelength, frequency, and energy. Thanks for watching.